Okay, so Evernode is a global, decentralized layer 2 network that is designed for hosting highly flexible and scalable decentralized applications that function as personalized mini blockchains that are known as app chains. This platform empowers developers to create dApps using their preferred language, functionality, and scale without needing to devise their own consensus mechanism. I'm telling you, one project you need to look out for in 2024 is Evernode, and this is an XRP ecosystem exclusive. Evernode has 5 key components. The first key component is consensus. Evernode provides a consensus as an operating system environment where code runs to enable multiple instances to function as a bespoke chain. The second component is hosting. Evernode enables the deployment of executable programs to a global network of independently owned and operated hosts. Evernode is a decentralized network. Evernode coordinates the network through a layer 1 chain called Zaha in order to ensure maximum security and decentralization. Number 4 is the native token. Evernode introduces a new digital asset called EVERS, ticker EVERS, to incentivize hosts and streamline automated payments for the network registration and hosting fees. Number 5 is decentralized governance. Evernode allows hosts to vote on updating rules for registration, rewards, and governance. This includes the ability to deregister unreliable hosts. There are 2 main roles in the Evernode ecosystem. The first is being a host, and the second is to be a developer. Anybody can become a host simply by downloading the Evernode software, paying the registration fee in EVERS, and building a reliable host using things like virtual private servers, watching out for your uptime, etc. I'll get deeper into that later. Anyways, reliable hosts can actually earn rewards and income in the network's currency by hosting decentralized applications. The second role in the Evernode ecosystem is as a developer. Given the global network of independently owned hosts, developers can build and deploy decentralized applications with their preferred specifications, language, behaviors, geography, and scale. Hooks is Zaha's light smart contract solution, which expands the range of use cases for decentralized applications, as well as the XRP ecosystem. Evernode is an initiative of Evernode Labs Party Limited, a private Australian company spun out of the Australian National University. It aims to commercialize intellectual property resulting from research funded by grants from Ripple's University Blockchain Research Initiative, or Ripple's UBRI. See, Evernode actually plans to launch fully functional on or by December 18th, but this is actually contingent on the activities of the Zaha network and the Sum team updating their app to Sum 2.6, which will be known as Zaman 2.6 from there on. This is because of the need of a wallet fully supporting the Zaha network and its XRPL account cloning feature. Evernode draws inspiration from the XRP ledger, envisioning a consensus engine where the payment app is replaceable with any other type of application. This led to the creation of Hotpocket, a unique consensus engine. You see, Hotpocket employs a cooperative unique node list, or UNL, based consensus algorithm. This is reminiscent of the Ripple consensus protocol, but abstracted for any type of transaction or input type. The Hotpocket consensus engine transforms standard applications into what are called decentralized applications, or dApps, which are essentially bespoke mini blockchains known as app chains that can be customized to behave as developers desire. Hotpocket provides a consensus as an operating system approach, where the various elements of the app chain, such as the unique node list, files, inputs, and outputs, are subject to consensus within the decentralized applications UNL. So there are 4 main components that come together to make up Hot Pocket. The first is the UNL consensus protocol. Hot Pocket is a unique node list based consensus protocol that allows multiple Linux machines to become a mini blockchain by simply enforcing consensus rules on inputs and outputs and maintaining a shared canonical state across instances. Hot Pocket also contains a bundle of additional features designed to make it as easy as possible to spin up a Hot Pocket node and sync it to the existing network. Hot Pocket also ensures all instances of a contract have the same configuration and allows contracts to be upgraded automatically at consensus. Through Hot Pocket, setting up a node is easy and can do it within the time span of simply a couple of hours. So what users can do is any node that doesn't ban you, you can connect to. Users identify themselves by proving ownership of a public key, and their inputs are then circulated into the consensus mechanism. This is like transactions being circulated into the Bitcoin or XRPL or Ethereum blockchains. During smart contract execution, the UNL nodes may communicate with each other over a broadcast service provided by the Hot Pocket. This is called the node party line. This feature allows nodes to run sub-consensus agreement and information sharing before exiting and alleviates the need for each node to behave completely deterministically. Once the smart contract is finally executed, another consensus round takes place to ensure all nodes produce the same output and the same changes to their state. Once the result of the execution is agreed upon, these user outputs are passed to their users for whom they were destined according to the contract's internal programming, or dropped if the user is no longer connected anywhere on the contract's network. In practice, this new consensus round also gathers up a new batch of user inputs to feed into the contract's next execution. So all that crap I basically just said, if you choose to spin up a host, you don't actually have to worry about any of that. Your host is doing all that in the background. You just have to worry about keeping your host online, essentially, and making sure that you're keeping up with the security updates for your host. But basically, everything I just listed is all to provide a robust and proven Byzantine fault-tolerant consensus mechanism that is agnostic to the nature of the app inside of it. So it works for any type of app whatsoever. So it works for any type of mini blockchain application running through Hot Pocket and through Evernode. So given Evernode's nature to handle any type of application, Evernode also wants to handle any amount of applications as well. And in order to do this, of course, they need to be able to rapidly scale the network. To enable new nodes to quickly catch up to state, Hot Pocket allows a state management system like BitTorrent. Each contract execution allows the contract binary to read and write into its state folder, which is in fact a mounted file system in user space device managed by a Hot Pocket subprocess. Each time the contract writes to or alters its on-disk state, the file system user space subprocess updates its Merkle tree representation of that contract state. The deltas between Merkle trees are then computed to allow efficient transfer of only the changed data between two arbitrarily distant states in the ledger chain. This means nodes do not have to replay old ledgers in order to catch up state, which would likely be otherwise impossible for high throughput contracts. Hot Pocket has two features to help elegantly manage contract lifecycles. The first is the online configuration. The contract configuration is subjected to consensus. This ensures all contract nodes use the same configuration, which affects deterministic execution. Contracts can also update their own configuration at runtime and rely on consensus to ensure all the nodes retain the same configuration. Second, Hot Pocket smart contracts can be configured to live among the contract data, subjecting the contract binaries and upgrade activities to consensus. Hot Pocket offers a handoff mechanism to perform contract upgrades in between consensus rounds by means of an installation shell script provided by the contract. The results of the upgrade are automatically validated in subsequent consensus rounds. Combined, these two contract management features mean Hot Pocket offers a rich administrative environment in which the contract can self-manage its own lifecycle. But despite Hot Pocket's utility, it would be a relatively centralized solution if developers had to spin up each of the machines on which their decentralized applications would run on. Instead, the proposal is that there should be a global marketplace of independently owned and operated hosts running software capable of hosting Hot Pocket decentralized applications. This network of decentralized application hosts is the problem that Sashimono solves. Sashimono is a hosting daemon. It provides the ability to deploy an instance of a Hot Pocket dApp to a shared Linux hosting environment and to have the dApp instance run without interfering with any other decentralized application instances running on the same host. Basically, it creates isolated environments on hosts for multiple decentralized applications, eliciting each decentralized application to function as a blockchain within its own ecosystem and environment. This all comes together to make Sashimono a multi-tenant cloud hosting environment specialized in Hot Pocket dApp deployment. Sashimono packages the Hot Pocket and dApp executables into a container image and runs them with the help of a security-hardened container manager. By placing the app in a container and bundling it together with any necessary dependencies, it also protects the rest of the system from any malicious applications. Hot Pocket uses a file system in user space or Fuse file system layer to help manage their dApp state. This provides for necessary Hot Pocket specific features, such as checkpointing and rapid state syncing. Granting containers access to the host's native Fuse device may become a security risk, so Sashimono actually maintains the state file system in an outer sandbox so that in this manner the container still has access to the dApp state file without requiring access to the Fuse device on the host. Each host is capable of operating separate instances of multiple dApps at once, without the apps potentially interfering with each other or with the operations of the host itself. Sashimono enables a decentralized network of hosts specializing in hosting Hot Pocket decentralized applications. All hosts that make up the Evernode network must be registered on the Zaha network through a registry hook or smart contract. If you watched my episode on Zaha, which you should, by the way, because it was really good. But if you haven't watched Zaha, Zaha is basically a code fork of the XRP ledger's open source rippled codebase. It embodies all the useful and innovative features of the XRPL, including its speed and low transaction costs, but tweaks and upgrades them in order to support smart contracts. Zaha is a sidechain of the XRPL. Zaha implements hooks, a smart contract technology that's developed specifically for the XRPL ecosystem. The Zaha white paper, as well as my episode, actually describes hooks as a small, efficient piece of code defined on a Zaha account that executes logic on transactions sent to or received by the account before those transactions are finalized in the ledger. Hooks are therefore a way for developers to create and deploy smart contracts on Zaha, thus opening a wide range of possibilities for decentralized applications and automated transactions in the XRP ecosystem. So hooks are a way of automating transactions received by and emitted from Zaha accounts. Evernode uses a hook set on a Zaha account to automate its canonical registry of Evernode hosts. The mechanics for registration and deregistration of hosts on the network relies on the hook auto-issuing and redeeming of registration NFTs on the Zaha network in exchange for a deposit of a certain amount of Evers, the native token for Evernode. This provides an additional point of utility for Evers and ensures the Evernode network isn't compromised by a centralized registry system that could be targeted and exploited. It's also important to maintain host quality in a decentralized way. At launch, this will be achieved in several ways. See, the first way is through giving people the carrot right away. They're giving you both the carrot and the stick, but they want to give you the carrot first in order to attract hosts in the first place. To earn network rewards, hosts must send a heartbeat message to the hook every hour. A host that fails to send a heartbeat message is classified as inactive, and inactive hosts are basically ineligible to earn rewards. This will be done by basically just making sure your host is online. Simple as that. The stick in this whole situation is that 80% of hosts will be able to vote to deregister bad hosts by forcibly redeeming their registration NFTs. So your official title and license to be a host can actually be taken from you if you aren't doing your job and keeping your host online. The penalty for unilateral deregistration is that the hook will rebate only 50% of their registration deposit and the other 50% to that epoch's rewards. Furthermore, anybody can actually send a prune message to the registration hook. In response, the registration hook will redeem or burn the registration NFT of any host who has not sent a heartbeat message in the last 10 consecutive days. So what does that mean? First, we're going to take your rewards. Second, we're going to take 50% of your deposit for actually registering a host. And third, we're going to just chop your host entirely. And the way they're going to enforce this is they're going to actually use bounties to incentivize the emergence of third-party audit services that use their host audit tool. It's going to be a tool for confirming that a host is properly configured to accept new decentralized application instances onto its slots. This is to provide host ranking services to dApps, developers, and the Evernode community. Immediately after launch, while the network is in its piloted mode, which I will explain later, I promise, Evernode Labs will perform on the side, and this entire system will be tweaked as the Evernode network goes live and faces the tests of the real actual world and real users. The way Evernode is designed is that it could have been actually built as a standalone chain to manage its own network registry and native currency. But the Evernode team chose to build Evernode as a layer 2 solution composed on another chain because of the benefits that come from joining an existing ecosystem. And it's a lot of benefits. You see, by issuing Evers as a token on a layer 1 chain, Zaha, they avoid the need to build an independent ecosystem of wallets, browser plugins, explorers, all that fun stuff that you have a million of in your phone already. I'm sure you don't need any more. Evernode will interoperate with existing Zaha tools like Sum, which will be known as Zaman after the latest update. Exchanges that support Zaha's native token ZA, XAH, can also easily support Evers. Second, there's going to be no decentralized unique node list. By issuing Evers on a layer 1 chain, they avoid the need for a separate Evernode network with a separate decentralized unique node list, and all the complications that come with specifying, identifying, incentivizing, and more long words that are involved in introducing another decentralized unique node list. But why choose the Zaha network out of everything out there? The way Evernode is designed is that it could have been nailed to any layer 1 chain with sufficient smart contract capabilities to issue tokens and function as a host registry. The fact is, Evernode is actually blockchain agnostic, but they chose to develop Evernode on the Zaha network because Zaha is fundamentally the XRP ledger, but with the hook's light smart contract amendment. During the initial conception and development, Evernode was intended to be launched on the XRP ledger. At the time, it was expected hooks would be adopted as an amendment to the XRP ledger, In the initial white paper, they actually noted that without hooks, they would need to pivot to an entirely new chain. As it became increasingly apparent to them that hooks would not be brought to the XRP ledger in any foreseeable future, they chose to experiment in the development of a new version of Evernode that didn't rely on hooks, where a multi-signature XRP account actually acted as the registry of hosts and the treasury of Evers. But this didn't work for a few reasons. Let's say you had someone like me who wanted to become a host. Guys like me, sometimes we can be very careless and we'll send the wrong amount of tokens, for example, to actually register in order to become a host. But with the XRPL, the transaction would still be deemed as legitimate and it would still enter the ledger. And then I would have to sit around and wait for my tokens to get sent back to me because I sent the wrong amount, or it would become a bigger issue where people can actually exploit that feature. Instead, with hooks instead of multi-sigs, the hook can actually reject a messed up transaction from Andrew, the XRP maxi. And that failed transaction simply will never enter the ledger, never confirm, nothing, and there's nothing to reverse. I have my money because they have dummy proof built into this layer 2. And that way, Evernode can also not be accused of wrongfully taking people's Evers and giving them nothing back in return. The second problem is that Evers could not be distributed as rewards to hosts. Those rewards would be controlled by a multi-signature account. And with multi-sig accounts, they're controlled by anybody who holds the keys. So this ultimately is going to be a huge problem security-wise and regulatory-wise and legal-wise. Like, somebody's going to get sued up the ass. All these issues arise from a limited number of people controlling the treasury of a blockchain project. Nobody would want to be the custodian of a project like Evernode. It's a recipe for disaster. So ultimately, the launch of Evernode on the XRPL for the time being is simply not realistic. It's impossible. Hence the development of Zaha by all the influential members of the XRP community involved. This is a sidechain that does everything in its power to hammer in the point that it just wants to be XRP, but with hooks implemented for smart contracts. Now, the part everybody actually cares about, the tokenomics. So Evernode uses a cryptocurrency called Evers, ticker EVERS. Evers will be issued on the Zaha network. Any Zaha compatible wallet will hold Evers. Since Zaha is a code fork of the XRP ledger, most wallets that support XRP will actually find it pretty easy enough to also support Zaha and therefore also Evers. All services on Evernode will be priced and paid for in Evers. Hosts will actually need Evers to pay for registration on the network, and tenants or decentralized applications will need Evers in order to pay for the hosting they're using. At launch, Evers will trade on Zaha's native decentralized exchange. Other exchanges could subsequently choose to list Evers, but since Zaha has a decentralized exchange, the protocol does not need exchanges to list the token for people to get it. Evers will not be distributed by presale or by ICO. The protocol will be launching fully functioning without pooling of any external funds for development other than grant funds. Evers will be gifted either via discretionary airdrops or distributed by a hook as rewards for running a reliable host. I actually run one myself, and mine is fucking reliable. So if you want a host for your decentralized app, you can pinpoint it to me and I will leave the domain for my host in the description. Pricing network services in Evers actually allows developers to automate their dApps buying and selling of hosting services from Evernode Host without a native digital currency and the related features of lease NFTs. This process would be prohibitively difficult or insanely centralized. So basically it would be dead on arrival. Evers will be instantly useful as a means of exchange for hosting services on Evernode, regardless of whether Evers actually have any value outside of the network. In the long run, the price, if any, of Evers should actually reflect the perceived value, if any at all, of the decentralized application hosting services that Evernode provides. And I'm sure you're wondering, Andrew, if this is meant to be just XRP with smart contracts, why don't these greedy ass developers just use Zaha or XRP as their native token? Well, during development, they did. They tried and experimented with building Evernode without a native currency. And the Evernode team explored the option of network registration and fees being paid in the layer 1's native currency, so XRP or Zaha, XAH. But this did not work. And it didn't work because it would mean they would have no proper mechanism for actually paying hosts for the work that they do. There could be no rewards for being a member of the network because the protocol has no rewards to give. And acquiring these rewards to give away for free would be prohibitively expensive. Furthermore, the potential tax implications would be insane if they had to buy and sell in order to pay their hosts every month. So because of this, the token is in fact needed for once in the crypto space. Second, it would have made the problem of also pricing network services almost impossible. It would be possible but impractical for hosts to adjust every single moment what they charge in rent based on the current value of XRP. But it would also be much harder for the protocol itself to adjust the registration fee. That would require a range of oracles and other complicated mechanisms, all of which can be gamed and lead to some undesirable outcomes. Why not just make a token and solve all your problems in one go? By having a native currency that's distributed in a fixed and decentralized manner, by having a smart contract or hook, they can avoid all these problems. In particular, they can even set the registration fee at a specific number of Evers, which is exactly what they plan to do, and let the market itself figure out what that fee should cost. So since Evernode uses hooks on the Zaha network, there exists a governance game in order to actually update these hooks in the future. And this function is handled by a third hook itself that implements that Evernode governance game. The governance game allows participants in the Evernode network to propose and vote on new hooks. These proposals will get accepted or purged according to a predetermined rule set on received votes. There are two classes of participants in the governance game, Evernode Labs, and Evernode Labs always gets one vote and also has special rights when the hooks are in piloted and co-piloted modes, but zero special rights whatsoever when the hooks are in auto-piloted mode. The second class of participant are valid hosts, accounts that actually hold a registration NFT for the 3 previous continuous months and are not eligible to be pruned due to being unreliable also get 1 vote each. So basically any host that's been running successfully and has a history of good uptime for the past 3 months gets a vote. And that vote is essentially equal to what Evernode Lab gets. So it's extremely decentralized. These votes are good for using on 3 different types of proposals. So participants can submit proposals for a new hook candidate, a proposal for a new type of hash for Evernode's 3 hooks. They can submit proposals for removing a dead host, as well as a proposal for changing the governance game mode. So changing it from piloted to co-piloted to auto-piloted. To propose a change to any hook, the proposer must present the hash of all 3 hooks that would apply if the proposal were successful. Any participant can submit a proposal for a new hook, so you or I can do it if you choose to run a host. The proposer must collateralize their proposal with an amount of Evers equivalent to the current moments reward quota, according to the Evernode reward schedule. So you gotta put your money where your mouth is. A dud host removal proposal nominates the Zaha address of the malfunctioning host to be removed from the platform. Any participant can submit this kind of proposal. A proposer must collateralize their proposal with an Evers reward worth 25% of the current moments reward quota. For submitting a proposal to change the governance mode, it is a little bit special. So the host that pitches a proposal can actually cancel their proposal at any time before it succeeds or fails. And if they choose to cancel it, the person who made the initial proposal gets half their Evers back. The other half is then added to that epoch's reward pool. If a proposal has not succeeded 3 months after being proposed, it will be canceled. And if a proposal expires, the proposer then loses all their oh shit. The proposer loses all their staked Evers. Lost Evers are then added to that epoch's reward pool. Hosts can make their own choice of voting via the Evernode CLI. The participant's vote is captured via their heartbeat, which is managed by the Evernode software installed on their host. They either support or reject a proposal, with rejecting a proposal being the default option. A proposal succeeds if it's supported continuously by at least 80% of possible participants for 2 weeks straight. If a proposal for a new hook candidate succeeds, after that, all other existing proposals for that hook are then canceled, and their staked Evers are added to the epoch's reward pool. As the licensor of the Evernode software and the developer of the 3 hooks involved, Evernode Labs has actually agreed to provide a limited, ongoing role to guard against catastrophic failure. First, a Zaha account controlled by Evernode Labs will always be eligible to vote. This means that even if there is nobody else eligible to participate for any reason, such as the registration hook becoming corrupted and all registration NFTs become invalid, Evernode Labs will then at least be able to vote to recover and restart the hooks. Second, Evernode Labs' vote carries special weight depending on the mode of the governance game. Remember, there's 3 different modes: piloted, autopiloted, and co-piloted. In the co-piloted mode, no proposal can succeed unless Evernode Labs supports it as well. So even if all the hosts support the proposal, if Evernode doesn't want it, it won't happen. In the piloted mode, Evernode Labs' vote determines the outcome of every single proposal. Point blank period. You don't get a vote. In the autopiloted mode, the standard voting rules apply, with Evernode Labs being treated equally with any other participant, so their 1 vote really means 1 vote. This is all done to provide a transparent and flexible framework for monitoring the performance of the hooks and ensuring everything is running smoothly before transitioning into a protocol entirely controlled by the participants. So it's guided decentralization with a focus on hardware decentralization right away, while providing the monetary support and the software support in order to do so. So the plan is to launch in piloted mode so that Evernode Labs can quickly address any catastrophic failure of hooks in the beginning. After that, they plan to move to co-piloted mode. This step will be taken as soon as it becomes clear that hooks are functioning properly and any catastrophic bugs are unlikely to emerge post-launch. Finally, if the governance mode is in co-pilot mode, it enters autopilot mode, again with the permission of Evernode Labs. At this point, Evernode Labs would then just become another participant and they would lose their special rights, except the persistence of its 1 vote at all times. You can't purge them, you can't cancel them. But keep in mind, if the governance game is in autopilot mode, participants at any time can vote under standard rules to return the game to piloted or co-piloted mode. Taken as a whole, Evernode's governance arrangements provide a transparent on-chain mechanism for participants to govern the 3 hooks in the long term, tempered by some temporary emergency powers available to Evernode Labs to quickly address catastrophic failure. The Evernode team is determined to succeed at any cost, and serious players in the industry have come to ensure this happens. Because of this, at launch, the protocol is designed to reward hosts simply for maintaining good practices. So there's plenty money and compensation to be made from day 0 from wanting to run a genuinely good business in an industry you're passionate about. I encourage anybody young or old, to give it a try if this genuinely sparks your curiosity. Why not? There's nothing to lose. The release schedule for hosts can be found on their website, and it's similar to Bitcoin, with early adopters being paid more tokens, in addition to the fees that the host will charge for transactions and running decentralized application. The lease NFT that hosts give developers represents a best endeavors promise to provide exclusive use of that slot to the holder of the lease NFT, so long as the hourly rent is paid. At any time, a host can revoke a leased NFT and cancel the tenant's decentralized app instance, or a tenant can just decide to stop paying rent. This needs to happen because hosts have no relationship to the actual dApp itself, but they may have real legal obligations to meet. Like, let's say you're hosting a dApp that unfortunately gets a copyright takedown request. It needs to go. Anybody can be an Evernode decentralized app developer as well. You see, Hot Pocket dApps, I really want to hammer in this point, they don't run on blockchains. They are blockchains. Each dApp is its own mini blockchain with its own chain history and dedicated nodes. These dApps can also be public or private. They may also call external services, read and write data directly to disk and to the web, and generally perform any task a regular program can, without centralization or third parties, and without requiring the programmer to implement their own consensus mechanism. Furthermore, because of Evernode's flexibility, Evernode dApps can actually be programmed in any programming language you wish to use. Evernode dApps can be deployed to as many or as few hosts as you desire, to also meet competing needs on your cost, security, performance, and censorship resistance. Through Evernode, the capacity for valuable and profitable business is at least as deep as the existing app market today. Evernode is an enterprise-ready Layer 2 solution to building decentralized applications in the modern world. This project brings the XRPL to the modern era, and I'm ending this podcast to go buy myself some Zaha and go get myself some Evers once the network is open. I'm Andrew, the XRP Maximalist, and GG. Send me some dope projects so I can make a video on it. Please and thank you. God bless you. Take care.